Estimation. So before going to know about estimation, first know about these notations. Estimate, estimated, estimation. So what is estimate? So estimate, simply we can say in one word, it is a statement. A statement given to unknown parameter. Unknown parameter. We know what is parameter and what is static. Parameter are sigma mu. Population related measurements are called parameters. Sample related measurements are called static. Sample related measurements like x bar s are called static. So here estimate is a statement given to unknown parameter. Statement means that is a sentence which is either true or false but not both. A statement is a sentence which is either true or false but not both. Here, like that statement, we don't know the population parameter, either mu or sigma or any other else, expecting that one through a statement. Here statement means that may be true or false but not both. That you need to remember. That is a simple sentence. We don't know one unknown value. We are expecting that may be this. That is called estimate. Estimator. Estimator means the method or procedure. The method or procedure to say the estimate. The method or procedure to determine unknown parameter. This is the method or procedure to determine unknown parameter. So how to find that unknown parameter? How to give that statement? Estimator is a method or procedure to determine that unknown parameter. We don't know one parameter. To find that parameter, what are the procedures, methods we are applying to find that? That procedures are called estimator. Now coming to our actual topic, estimation. Estimation is the process of determining. The process of determining estimator. In such a way that is close to actual or parameter value. The process of determining estimator. Finding estimator that is very close to that unknown value. So simply what you can say, estimation is process of expecting some unknown value which may be close to actual value. That process is called estimation. In general way, we will take estimation. Estimation is not final. If you want to buy something, you will take estimation. That estimation gives approximate value. If you go for purchase that product, then that estimation value may differ with actual. But that estimation is close to actual. Close to actual means that may be greater than or less. Maximum less. That process is called estimation. So estimate means a statement given to unknown parameter. You don't know some population mean, expecting that population mean may be this value. That is estimate. How you are expecting that statement? On which procedure you are expecting that mu value is that value? that method or procedure to determine that unknown parameter is estimator. The estimation is the process of determining good estimator. We can expect after writing an exam, one can say easily, I may get 50, 60. But after getting results, if he say 50, if he will get near to 50, that may be 51 or 48 or 47, then that estimator is a good estimator, we can say. So, to expect that 50 marks after writing exam, he need to go a procedure. How many questions he written? For every question, how many marks he will get? That procedure he has to follow to find good estimator which is close to actual. So here, this estimation process, types of estimation are two types. We can expect one unknown parameter value using estimation in two ways. One is point estimation. Another one is interval estimation. Point estimation, interval estimation. So what is point estimation? Point estimation means expecting unknown parameter value with single numerical value. Expecting unknown with single numerical value. So what I mean to say here is, just now I said one example, after writing exam, expecting our marks with single value. I may get 50 marks, I may get 70 marks, I may get approximately 40 marks. How you are estimating your marks? Like single value. So if theta is unknown parameter, we represent that single numerical value what we are expecting, that is theta cap. This is estimated. So expectation of theta cap is theta, then that estimator is unbiased estimator. Generally we expect some unknown value, but they may not be equal to actual, but they may be close to actual. If that is equal to actual, if you expect 50, if you get 50 marks, then expectation of theta cap equal to theta. There is no bias, there is no error in your expectation. So in point estimation like this, we are going to expect that unknown parameter value. But this point estimation rarely coincides with actual, because you are expecting with a single numerical value that unknown parameter value. If you expect 50, if you get 51, that is not exact estimation. Even though that is very close, but what you were expected, it is not getting. That 50 expected, 51. Even though that is close, but what you expected is not getting. What I am saying, expecting an unknown value with single numerical value, there is very less chance to coincide with actual. But to overcome this one, we use generally interval estimation. Interval estimation means expecting unknown parameter value with an interval. Expecting unknown value in an interval using two values. How many marks you may get? If anyone asks after writing exam, I may get in between 50 to 60. Then if you get 55, your estimation is correct. If you get 59, your estimation is correct. So you have so much of chance to have to get your estimation success. Your expected value may coincide with actual if you go for interval estimation. If theta is expected unknown parameter value, theta L is lower limit, theta U is upper. These two values, what I said, 60 to 70. If you want to buy a laptop with some configuration, if you ask your friend, if you say with one number that may be 30,000, if you go there, if it is 32 or 35,000, that what your friend said is not coincide. But if your friend says like this, that may be between 30 to 40,000. If it is 35, you may be satisfied with your friend's estimation. So expecting some unknown parameter with an interval using two values, there is more chance to coincide with actual. That type of estimation is called interval estimation. Whenever our expectation, estimation is not coinciding with actual, there we say that some error is there. That error, for example, I expect 50, if I got 51, what is the error? 1. That error is called maximum error. Emax we call that one. How to calculate that maximum error? How to calculate these estimators? We will discuss. An estimator is said to be good estimator, unbiased estimator, if expectation of theta cap equal to theta. It may happen very rarely. Unbiased estimator, good estimator, we can say. Estimator means nothing, the process of determining unknown parameter value. Estimate means nothing, that is a statement given to unknown. How you are saying, I may get 50 marks, that is a statement. You may get 50 or you may not get 50. To say I am getting 50 marks, you undergo one process. That process is called estimation process. The types of estimation: expecting unknown with single is point, expecting unknown with interval is interval estimation. Very clear? For large sample, we discussed already. Large sample means size of sample is greater than 30. We call that one as greater than or equal to 30. We call that one as large sample. For large sample, we are going to find maximum error of estimate and also confidence interval also. Confidence interval for large sample also we are going to find. For that, I am taking this one. Normal curve, you know this. This is in bell-shaped curve, which never enter into x-axis. In this, we call this region as rejection region. This is rejection region. We call this one as acceptable region. Acceptable region. We also call this value as a critical value, which separates acceptable region and rejection region. If you take alpha by 2 is alpha is rejection, that means that will be on both sides, alpha by 2 and alpha by 2. Alpha, we call that one as level of significance, which is rejection percentage. That is distributed on both sides, alpha by 2, alpha by 2. We all know that total area under normal curve is 1. Total area under normal curve is 1. This is alpha. If you subtract alpha from 1, you will get acceptable region value. That is 1 minus alpha. This is acceptable region. Now, this value is minus z alpha by 2 because left side. This is plus z alpha by 2. Plus because that is on right side. This is z line. Now, the probability of z between minus z alpha by 2 to plus z alpha by 2 is 1 minus alpha, that is acceptable region, 1 minus alpha. But in large sample, z equal to x bar minus mu by sigma. In large sample, z equal to x bar minus mu by sigma by root 10. Z random variable. Now, if you write in the place of z that value minus z alpha by 2 less than z is x bar minus mu by sigma by root 10 less than z alpha by 2 equal to 1 minus alpha. Now we need to find the confidence interval for x bar. For that I am taking sigma by root 10 to this side. If you take sigma by root 10 to this side, that means multiplying with sigma by root 10 minus z alpha by 2 into sigma by root 10 less than x bar minus mu is less than z alpha by 2 into sigma by root 10 equal to 1 minus alpha. Now multiply with, add mu or add x bar to find confidence interval for mu. If you add x bar on both sides, x bar minus z alpha by 2 into sigma by root 10 less than minus mu less than z alpha by 2 x bar minus x bar plus z alpha by 2 sigma by root 10 equal to 1 minus alpha. Probability of. So if you multiply this one with minus sign, this term comes to here, that term comes to there. That means probability of x bar plus z alpha by 2 sigma by root 10 less than mu less than x bar minus z alpha by 2 by sigma by root 10. So here that is confidence interval. Confidence interval for population mean mu is x bar plus or minus z alpha by 2 into sigma by root 10. The z alpha by 2 is z distribution value we will evaluate. X bar is sample mean, sigma is SD of population, n is size of sample. This is formula to calculate confidence interval for large sample. Here z alpha by 2 into sigma by root 10 is called maximum error of estimate. Maximum error, that is E max. Formula is z alpha by 2 into sigma by root 10. So this is formula to calculate maximum error of estimate for large sample. Maximum error of estimate for large sample. If you want to calculate for small sample, we use t distribution. T alpha by 2 into s by root 10. In the place of sigma you will get s. In the case of small, this is for large sample we are discussing now. Large sample. So these two formulas you have to remember. I explained how we got that formulas. Maximum error of estimate. So a random sample of size 100 has SD5. What can you say about maximum error with 95% confidence? So here given sample size is 100. 100 means that is large sample. Greater than 30, that is large sample. And for large sample, SD means you need to consider that one as population SD. Sigma is given. And alpha by 2% is given. Confidence percentage 95% is given. For 95%, Z alpha by 2 is 1.96. So Z distribution table values are like this. Z alpha by 2 is 1.96 for 95%. Z alpha by 2 is 2.33 for 98%. Z alpha by 2 is 1.645 for 90%. Z alpha by 2 is 2.58 for 99%. 2.58. So for large samples, you need to remember these four values. Z alpha by 2. For 95%, 1.96. Now we need to find maximum error. E max we need to find. Maximum error of estimate. The formula for E max is Z alpha by 2 into sigma by root n. What is Z alpha by 2? 1.96. Sigma is 5 by root 100. Root 100 is 10. 5 by 10 you will get. 5 by 10 is 1 by 2. 1.96 by 2. So you will get 0.98 maximum error of estimate. Like this, one can easily evaluate maximum error of estimate whenever size of sample SD is given. If it is large sample, we will take Z alpha by 2. If it is small sample, we will take T distribution. That is T distribution table value we need to see. So given, assuming that the SD 20.0, how large a random sample be taken to assert with probability 0.95, that the sample mean will not differ from true mean by more than 3.0 points. Here, how large a random sample? That means we need to find size of the sample, small n we need to find. What is given? 0.95 means 95% probability, and it should not differ from true mean. 3 points means maximum error is 3. So what is given here? Here given is E max 3 maximum error, and for 95% given Z alpha by 2 is 1.96. This is the value which you need to bear, like 4 values you are having. 95% 1.96, 90% if you have 1.645, 99% 2.58, 98% 2.33. I written that one, that box already. So Z alpha by 2 is 1.96, E max is given, and SD also given, sigma 20. Now we know maximum error formula. E max is Z alpha by 2 into sigma by root n. From this, root n is Z alpha by 2 into sigma by E max. So squaring on both sides you will get n value. Z alpha by 2 into sigma by E whole square. So n equal to, substitute that values. Z alpha by 2 is 1.96 into sigma value is 20 by E max is 3 whole square. If you calculate using your calculator, you will get size of sample 171. A random sample of size 81 was taken, whose variance is 20.25 and mean is 32. Construct 98% confidence interval for large sample. So you need to use 98% confidence limits for the given large sample, because size of sample is 81 given n equal to 81, which is greater than 30. So this is called as large sample. Okay, for large sample, confidence interval has formula. First I am writing given data. N is 81, size of sample greater than 30, large sample, and the mean, sample mean x bar is given 32. For 98%, Z alpha by 2 is 2.33. For 98%, Z alpha by 2 is 2.33. So substituting these values in the formula, confidence interval formula. Confidence interval for large sample, because this is large sample. X bar plus or minus Z alpha by 2 into sigma by root n. Sigma also given. Variance. Variance is given. Sigma square is given 20.25. We will write root 20.25 value. So here confidence interval x bar plus x bar minus Z alpha by 2 into sigma by root n, comma x bar plus Z alpha by 2 into sigma by root n. Substitute that values, you will get x bar 32 minus Z alpha by 2, Z alpha by 2 2.33 into sigma root 20.25 by n root 81.9, comma 32 plus 2.33 root 20.25 by 9. So if you calculate this value using your calci, you will get 30.835, 33.165. This is confidence interval for the large sample using given data.